Hey everyone, Mr. Ray here with our next lesson in data management. Unit 1, we're looking at ways of counting things. It's called permutations and combinations. Okay, so in the last lesson we looked at combinations, which were basically the ways we can select items when the order does not matter. Okay, and that's some of the examples. Maybe choosing a committee of people instead of choosing positions in the committee. So if you're just looking for a group of people and the order doesn't matter, or a group of cards, you're going to be using combinations. Okay, so this lesson is kind of like an offshoot of that. We're still working with combinations, but this is a slightly different way of looking at combinations. So again, the order for all of these cases, situations, the order does not matter. It's just whether or not we're selecting it or not, okay? Now, before I get to the actual formulas here, I want to jump right into the examples, and then from the examples we can see where the formulas come in. So the first example, an artist has an apple, an orange, and a pear in his refrigerator. How many ways can the artist choose one or more pieces of fruit for a still life painting? Okay, so you got three things. In this case, they're all unique. So I'm going to show this through a tree diagram. So for each choice, you've got three things. You've got your apple, orange, and pear. Now, one way of looking at this is for the shots or for the painting, we can either use the apple or we don't use the apple. So that's like almost like two branches for each of these. So use, not use, use, not use. You won't have to do this every time. This is just to show where the formula comes from. So we actually have two choices for each of the three unique things. So if we looked at the number of choices here, if we looked at the end here, you could just count it up. Well, actually, no, that's not right. But for the apple, if you're looking at the apple, how many ways can we choose the apple? We can choose it two ways. So that's going to be two ways. Now we're also choosing an orange. So this is not an or, this is an and situation. So again, for the orange, we have two choices and we're going to multiply. So that's four ways so far of choosing an apple and an orange. And then of course, two ways to choose the pear. So we basically got 8 selections. Now, one of these 8 selections is if you chose not to use all of them. So one of those 8 is choosing nothing, but the question was specific in saying that you have to choose one or more. So basically this is saying you can't choose nothing. You have to choose something. Okay, so we actually have to remove one of those choices, which is in this course in statistics, we call this the null set. The null set just means nothing was selected, but it's still a choice. So that becomes 8. Well, one way to write this is 2 cubed minus 1. So that's 8 minus 1 equals 7. So there's actually 7 different ways of choosing fruit, these 3 pieces of fruit in a picture. Now, the order that the fruit appears in the picture is not important. It's just whether or not it's in the painting or not. Okay. So if we have these unique things and we can either choose them or not choose them, the total number of choices, you can see, well, in this case, the number of things we had was 3. So in our case, this is actually n equals 3. So the formula, you can see where that 3 comes in. We basically multiply by 2 that many times, or in other words, 2 to the power n will give us the total number of choices, but that also includes the null set. So if we go up to here to our definition here, set with n distinct elements, distinct meaning you could tell them apart, apple, orange, pear, has 2 to the n subsets or ways of choosing them, including the null set. Okay, so when we did our calculation, we did the calculation 2 to the n minus 1 because we didn't want the null set. We didn't want to have nothing in the painting. Okay, so that's one way of looking at it. Either for distinct items, you can either use it or not. So if you have n distinct items, the number of ways of selecting them would be 2 to the power n. And if you don't want to include the empty painting or the null set more generally, it's going to be 2 to the n minus 1. Okay, let's kind of apply that to our second example. In how many ways can a committee with at least one member be appointed from a board with 6 members? So you've got these 4 distinct people, no twins, or well, I guess even if it was a twin, they'd have a different name. But so the number of committees we could have, we're choosing from 6 choices. So we could have committees basically from no people to all 6. So again, it's a matter each person we could use or not use on the committee. So it's going to be 2 to the power, so in this case n equals 6, 2 to the power 6. And again, it was conditional here with at least one member. So that's another way of saying take away the null set, which is the same thing we did on our last example. So the number of committees is 2 to the power 6 minus 1, which is 64 minus 1, which is 63 different committees. Okay. Very quick, easy calculation, but again, you have to think about it. And again, you can only use this formula 2 to the n or 2 to the n minus 1 if the items you're selecting from are unique or distinct. Okay, if you have multiple items of the same, you cannot use this formula. So what do you do? So let's go to the third example. And from this third example, we'll come up with the other formula. So Kate is responsible for stocking a coffee room at her office. She can purchase up to 3 cases of cookies, 4 cases of soft drinks, and 2 cases of coffee packets without having to send the order through the accounting department. How many different purchases can Kate make? So we're looking at combinations of buying cookies, soft drinks, coffee packets where she doesn't exceed she doesn't go above 3 cases of cookies, 4 cases of drinks, or 2 coffee packets. So it's a similar idea here, but this is obviously different because you have some identical items. Okay, so if I'm looking at the total number of purchases that could be made, if I start with the cases of cookies, so we could have up to 3 cases of cookies. So how many cases could we put on the purchase order? We could put 3, we could put 2, we could put 1, or we could put 0. So so basically what we do is we take the number of items for that, which is up to 3, and we add 1. So the 1 is basically the choice of not ordering it at all. Okay, so that the cookies is that entry. And we're going to multiply, well, obviously that's 4. Now we look at the 4 cases of soft drinks. Okay, so we could order 1 case, 2 case, 3 case, 4 case, or no cases at all. So that's going to be 4 plus 1. I'm just putting the plus 1 in here so you see where it comes from. So we can order up to 4, which includes 0. So there's actually 5 different orders possible with just looking at the soft drinks. Okay, and then same idea with the coffee packets. This time we have maximum 2, so we could order 1, 2, or 0. So we add that 1 just to show the option of ordering nothing. Now, obviously, if you think back to what we just did with the 2 to the power n, this will also include one option, just like the other examples did. One of these, if we multiply these together, one of those purchases would be a purchase of nothing. Okay, and obviously that's not really a purchase, so we have to apply the same technique we did before. We're going to subtract 1, which is, hopefully you remember the name, null set. And now we just do the math. So it's 4 times 5 times 3 minus 1, and that's equal to 60 minus 1. So 59 possible different purchases. Okay. If I go back to the first page, you can see this in the key concepts. We use the formula p plus 1 times q plus 1 plus r, times r plus 1, ... There could be many of these or just 2. And then the subtract 1 to find the number of selections of at least one item that can be made from p items of one kind, q items of another kind, r of a third kind, and so on. So that's the generic formula, and basically we just put in our numbers of 3, 4, and 2 into this to get our equation. Okay. And hopefully you see the reason for the subtracting 1 is the 60th possible purchase would be ordering nothing at all, and that doesn't really count as an order. So we subtract that and get a total of 59 possible different purchases. Okay, this last one, combinations with some identical items, and we're going to actually do 2 different methods for this. The director of a short documentary has found 5 rock songs, 2 blues tunes, 3 jazz pieces that suit the theme of the film. In how many ways can the director choose 3 pieces for the soundtrack if she wants the film to include some jazz? Okay, so as soon as we added that last part there, it became a little more complex. If we just wanted to know the total number of ways of choosing 3, that would be a fairly simple combination. So I'm going to show you 2 different ways of doing this. The first way is the direct method. We usually don't call it that, but the second method will be the indirect method. So using the direct method, we're going to break this down into 2 cases because she wants to include some jazz, and there's a total of 3 pieces or songs that we're choosing in total. So we're going to have a case of choosing 1 jazz song, the second case of choosing 2 jazz songs, and 3, and we're going to find the totals for those and add them together. So case 1 is 1 jazz piece. I'll just write them out here so you know what's coming. Okay, so the number of ways of choosing 1 jazz piece. Okay, so if we look at, first of all, how many ways can we choose 1 jazz piece? Well, that is, we've got 3 jazz pieces. So this is a combination, 3 choose 1. So that would tell us how many ways can we choose our jazz song that's here. Okay, and then, so we've only picked the jazz songs so far. Now we pick the non-jazz songs. So how many non-jazz songs? Well, we got 5 rock and 2 blues, so we've got 7 non-jazz. So that's 7 choose. And since we've chosen 1 jazz song, out of our 3, that means the remaining 2 have to be non-jazz. Okay, so this is really 2 different combinations. First of all, choosing your jazz song and then choosing your non-jazz songs, in this case 2, and that's going to be 3 times 21, which is equal to 63. So there's 63 ways to choose choose your 3 songs where one of them is a jazz song. Okay, same idea for 2 jazz songs. Calculations are very similar. So this time to choose our jazz songs, this time we're choosing 2, so it's going to be 3 choose 2 this time. And our non-jazz songs still have 7 to choose from, but this time we're only choosing 1 because the other 2 were jazz. Okay, so that's going to be, again, 3 times, this time it's 7 for the non-jazz, so that's 21. Case 3, we choose all 3 jazz songs. So the number of ways, and you could think of this in a simpler way, but you can kind of follow the pattern of what we're doing here. This time it'd be 3 choose 3 for our jazz songs, and 7 choose. And this time we've already chosen all 3 songs, so there's nothing to choose from. Okay, so if you do your combinations for that, how many ways can you choose 3 things from 3? Well, that's just the one way. And how many ways can you choose 0 things from something? Well, that's also 1. So there's only one way of doing that. Okay, so now that we've got, this is all 3 cases of at least one jazz song. So we take our totals for each case, and because it's case 1 or case 2 or case 3, the word or tells you it's going to be adding. This is the additive property of counting. So when we add those up, we get 85 ways. Okay, so let's try this another way. And I'm not saying one way in this case. They're both probably good candidates for doing. You want to pick, for you want to pick the easiest way every time. So if you think about indirect method always means you're starting with the total number of all the possibilities, and you're taking away, you subtract the ones that you don't want. And that will give you, if you subtract the ones you don't want from all the possible options, that should give you the options that you're looking for. Okay, so I'm going to start off with number of ways to choose any 3 songs. So this would be all the possibilities. So any 3 songs. So that's equal to, now we have to go back to our numbers here. How many songs do we have to choose from? We have 5 rock, 2 blues, and 3 jazz. 5 plus 2 plus 3 is 10. So we start with 10 songs and we're choosing 3 of them. So if we do that combination, we get 120. So that's the number of ways to choose any of the 10 songs. Okay, now what don't we want? So this says it wants director to choose 3 pieces for the soundtrack if she wants the film to include some jazz. So, you know, the direct method was 1 jazz, 2 jazz, or 3 jazz songs. So what don't we want? We don't want no jazz. Or in other words, all 3 songs would be non-jazz songs. So that should be fairly easy to count. Number of ways to choose 3 non-jazz songs. So that's equal to, so again, so how many non-jazz songs do we have? We did this before, it's 7. So how many of those 7 non-jazz songs do we want to pick? Well, if we're picking 3 non-jazz, we're choosing 3. So 7 choose 3 is 35. Okay, so if we look at these numbers here, So with the indirect method, I've already talked about it. You start with all the possibilities, and what we do is we subtract the ones that we don't want, and that's exactly what the 35 represents. So this is indirect. So indirect, we always subtract total possibilities from possibilities we don't want. Okay, so 120 minus 35, again, 85 ways. Okay, so in terms of time-wise, both of these methods took about the same, although you might say that indirect was 2 calculations compared to 3. When you start doing some of your probability calculations in the next few units, you're gonna have to choose between direct and indirect, and a lot of times it's quite obvious. Instead of doing 14 calculations using direct method, maybe you should do 2 calculations using indirect. So again, choose. It's a choice that you make, and everybody wants to do the choice that requires the least amount of work but gets the correct answer. So this is an example of that. Okay. So if you look at the key concepts, again, there's a couple of entries here about looking at all the possible cases, which we did have a couple of examples that worked at that. We had we only had one example, but using the direct method, for example, 4, we had to look at cases because there was cases of using 1, 2, or 3 songs, and we had to do a different calculation for each one and then add them together. Okay, so that'll be it for combinations. I've got some homework here to try out using the formulas and situations we've talked about in this lesson. The next lesson, I believe, it's Venn diagrams, which is pretty interesting and important method of counting and looking at all the possible combinations of things. And then we'll end the unit with looking at Pascal's triangle, which is a very interesting tool used for counting. Okay, so that's it for today. We'll see you in the next lesson. Have yourselves a great day.